So, oops. Okay, continue what you talked in the last class, the last session. Again, we talk about the handoff because it's important to star topology. But there are some technologies that don't use star, or in other words, using different topologies that, for example, this one, the A0254. The A0254, it is the base of, for example, the ZigBee or the base of the 6LoWPAN. In this technology, you use a different approach. You use a mesh network. It's not exactly a mesh, we'll see in the next slide, but try to emulate a mesh network. What is a mesh? A mesh is a topology where each node connects with the other, with all nodes that you know. For example, okay. Think this red node here, okay? The red node connects with the green node, the blue node, and the green node here. Because it is the node that is in the range of the red. Why the red does not connect with the blue? Because it's not in the range. Did you understand? The idea of the mesh in the practical perspective is you connect with all nodes that is in your range. What it means, for example, the red, think about the red, okay? The nodes that is in the range of the red is the yellow dash. Think another one, we talk about this blue here, okay? The blue here. The blue here knows this node here, okay? Because it's in the range. Another one, this green here. The green here in the range has only this one, okay? It's the main idea of the mesh. You try to connect every node that you know. Did you understand? Any questions about the mesh? What is the good thing in the mesh network? We're back to the last slide. If you lost this guy here, what happens with the notebook, for example, with or notebook 1, notebook 2, tablet 1, tablet 2, to connect the internet? This guy can connect the internet or not? Does this guy, for example, notebook 1, does notebook 1 connect the internet with this access point go out or go off? Yes or no?
No, because that's the access point to from the cloud, no?
Yes, because it's a star. If you lost this guy, you lost your network. Okay, you need this guy to connect to the other guys. Okay, so, but think here. Think the red node, okay? If you lost this node, you continue to have access to the server, yes or no?
Well, yes, unless you lose the access point, no?
Yes, because here it's a mesh. If you lost this guy here, you can go to the node for this path, or you can go to this node using this path, or you can go to this node using, for example, here no. Here you cannot. For example, using this path or using this path and others, no? You have multiple paths to acquire your destination. Did you understand? Yes or no?
Yes, teacher.
Okay. It's the reason that mesh network is good. The problem is the mesh network has some problem. First good thing, you have a low cost, okay? These wireless need to have a low device. The device is not so powerful and not support low data rate. It's because you have when you have one only access point, you can create, for example, in your access point, you can create, you can have a device that has a lot of features, a very advanced features, because you don't need to have multiple devices like that. You need to have few devices like that. For example, if you have 1,000 users, you need maybe one access point only. It's different here. Each node in the network is an important node in the network. For example, your Wi-Fi, your device is a part of the network. Sometimes your device works like a user, sometimes like a server. Okay. One important thing is the installation. Remember the Wi-Fi, you need to define the SSID and need to define the key. The A0254, most of the time, it has out configuration. You turn on, it's like a turnkey. You turn on the equipment and the equipment out configure and out join in the network. Okay, it's making that this technology is very simple and flexible. Okay. It's a good approach to home and building automation, automotive networks, industrial wireless networks, and toys like games, remote controls, and others. When you analyze this protocol in detail, it's the last picture in the protocol is like that. Okay. You have some nodes that assume, I try to explain better this. If you see here, you have a mesh, but the implementation of this technology is not exactly a mesh. You create something like a tree, okay? Did you remember tree? You already studied tree forest in the hours or data structure, am I correct? Did you have class about the trees? Yes or no, guys?
No, teacher, we don't know.
You don't have a data structure course yet? You study, for example, stack, or yes or no?
Yes.
Yes. Maybe you study binary tree or something like that. Am I correct?
We're beginning with binary tree.
Okay, okay. So a tree is a data structure that you have the root, no, and you have leaves, no. Here you have another root and you have three. If it's binary, for each root you have two leaves. If it's not binary, you can have multiple leaves. Okay, it's what happened here. Okay. When you start the network out configure and define one node that is the root of the tree, is the network coordinator. Okay, and this node, again, you reshare, you start to negotiate and define a PAN coordinator. What is a PAN coordinator? Is a coordinator that is responsible for a small area, a very, very small area. Remember the personal area network? You study local area network, personal area network, wide area network, and oh my gosh, the metropolitan area network. The PAN, or the personal area network, is a very small network. Yes, trees, exactly. It's the idea. You have the network coordinator that design small cells. Things about the PAN coordinator is a small cells. For example, things that you install this technology, for example, in the build one. Okay, you have the equipment's out configuration, out negotiate, and select or elect one node to be a network coordinator. And after you select the network coordinator, you start to negotiate again and select, for example, one PAN coordinator for each floor in the builder one. Okay? And after it, you have nodes. Okay? If you see in the big picture, it is the topology that you see, a mesh. But if you put a look and see in detail, you have something like a star. Okay? You have two protocols that implement the 802.15.4, the ZigBee and the 6LoWPAN. The ZigBee is the oldest protocol. It's very famous in, I cannot remember, is in 2000. And the people, when the ZigBee was developed, the people think, oh, it is the protocol to use in IoT. But the ZigBee has some problems. For example, ZigBee don't have a lot of security features. Okay, in that time, security is not so important than now. Okay, and another thing that ZigBee is not scalable. For example, I work in a project to create a smart city in Brazil, and you need to connect around 5 million devices. ZigBee does not support 5 million devices. It's crazy. It's impossible to manage a ZigBee network with this number of devices. Okay, it's the reason that the Cisco creates a new protocol that is 6LoWPAN. 6LoWPAN is similar than ZigBee. Okay, it uses this approach here. However, supports millions of devices. Okay. Another important thing that 6LoWPAN has is a very strong authentication and there are very strong security features like cryptography and others. Okay. I believe when you study, for example, in the first class, not all students, but some students need maybe when you study, for example, the first exercise where you prepare a PowerPoint about the Cisco IoT solutions. Probably you study one example, one case that you use 6LoWPAN. Okay. The problem of this technology is you don't have a lot of, you cannot transport a lot of data. Okay. You have a lot of connections. It's very good connectivity, but it's very bad when you need to transport, for example, videos, for example. Any questions? Okay.
No, teacher.
It's what I told you, no? You, for example, with 6LoWPAN, you have more security, you have frequency hoping to support more device, okay? And 6LoWPAN is the implementation that you use in some implementation of the smart city, for example. There are some protocols that is specific to smart grid because the first use The first sector that needs a small device and to connect a lot of device is the electricity sector. It's the first case. Now you have a lot, but in the beginning, 10, 15 years ago, is because you need to create a smart grid, you need to develop protocols, and you start to have protocols to attend only the smart grid. This picture here represented in the left, the old electricity industry. Okay, you have a few large power plants, okay, that send the electricity to distribute this electricity to the house, okay, use a lot of pipelines, a lot of infrastructure, and the flow of electricity is all the time from the power plant to the house. What happens in the last years? You start to have very small productions. For example, I don't know, maybe you have in your home a solar panel that produces electricity to take shower or to heating something in your home, okay? In Brazil, for example, in the northwest of the Brazil, you have a lot of wind and you have wind panels, okay? Is this structure here, okay? And what happened now? Here in Brazil, you have some builds in some house that produce more electricity than consume. Because in the beginning, you install a solar panel in your home to produce electricity to you. But sometimes you don't consume, you generate more power than you consume. And the new idea that you can sell the residual electricity to other people. What changed? In the beginning, all the flow is power plant to house. Now you have both directions. You have some house that produce electricity together the power plants. The problem is you need to have an infrastructure to manage these things. You need now, in the beginning, you don't have a lot of device that you need to manage. Now, the home is a device that you need to manage. This technology, the smart grid, the green one, enable, for example, that you can calculate the consume of one house instantaneously in real time. It's good, for example, for the companies, because if you don't pay the electricity, you don't need to send a guy to cut. You can send a command remotely, okay? It's a very good thing because, for example, in Rio de Janeiro, the company that provides electricity in the city lost around 50% of electricity in the house, in the favelas. I don't know, you know what is a favela? Do you know this term?
Like big houses, right? In the mountain.
Favela is a very, in Brazil, okay, in the Portuguese, favela means a community that you don't have, the house is using wood, or you don't have a very good, it's not a very good place to live. It's what means favela in Rio, in Brazil. I don't know if it's the same meaning in the Mexico. For example, in that time is the place, for example, where the drug lords, you have a lot of gangs, you have a lot of crimes, you don't have water sometimes. In this place, the people don't pay for electricity, okay? And it's very hard to go. For example, the people don't pay. Who pay? The other people, no? And the company lost around 50% of the production of the electricity in this place. And you cannot go to this place to cut the electricity to people that don't pay, because you need to enter in the very dangerous place. Using this technology, you can you can turn off the electricity from a specific house remote. You don't need to expose. Otherwise, it's good to the people too, because things that you pay your electricity, for example, you can see immediately your consumption. For example, you can, like an application, you can open an app and see, oh, I spend the electricity now is very expensive. If I use, I don't know, 10 minutes, 1 hour late, I pay less. And you can accommodate your consume to the best voltage that you want. Did you understand what is a smart grid, what I told you here?
Yes, teacher.
So to support this technology, okay, to support when you start to create this technology, the smart grid, the people start to think, okay, okay, it's nice technology, you can connect everything, you need connectivity, but you have a problem. You don't have, wireless does not support, remember, it is in 1995 and 2000, wireless is in the beginning. The people said, okay, wireless is not an option, okay? And to use fiber or cabling, you need to install a lot of cabling, okay? The idea was, okay, why you don't use the same cable that I pass electricity to pass data? Okay, why I don't use electric cable to transport data? Not only transport electricity, but transport data. It's what is the idea of PLC. The PLC is a technology that you use the electric cable to transport data. It's a non-solution, for example, for specific. I use this technology in my home in West because I have 3 floors in my home in West, and I don't I don't have wireless signer in the basement, and to connect the rest of the house with the basement, I use an adapter, a PLC adapter. I connect this PLC adapter in one socket in the first layer, in the first floor, and I connect another socket in the basement, and I transport the data using the electricity cabling. Okay. In the US works very well because the electricity and the infrastructure to transport electricity is very good. In Brazil, it's not work very well. Okay, I don't know Mexico, but it's the idea. You use power line to transport the data. The PLC, you have different approach to low voltage to homes, medium voltage, for example, to industry, and to high voltage to manage data, for example, to SCADA and the management system in the smart grid. This technology today in the world, you have limitations. It's not because the wireless is become very powerful today. You don't have a lot of implementation. You have some implementation in the year, okay, but it's not so common. Sometimes you use PLC in part of the network, in the specific parts of the network that you don't have good wireless. In particular, for example, things that you need to install. You have a smart grid, you need to install the network device to control, for example, the metro. Not the metro, superficial metro, but the metro that is underground. the wireless does not work with that. And you can use PLC to complement the wires, the big wireless network. Did you understand the example?
Yes,
Yes,
teacher.
okay. So, as I told you, you have the LoRa, okay? LoRa is the technology, LoRa 1 is the protocol, okay? It's only if you say, oh, LoRa 1 or LoRa is the same. In the LoRa is a wireless protocol that is more strong than, for example, the 6LoWPAN. It's not a mesh topology, use a star topology, okay? But use a, it's not a proprietary protocol, but it's a really new protocol. And the idea is you have your end nodes, for example, smart meters, humidity sensors, and others. And these nodes connect with gateways, node gateways. Okay. And these node gateways connect with the 4G, 3G, 5G, or other backhaul technology or backbone technology to connect with the server. Okay. LoRa is not a real technology to use in a very, very, very large range. For example, LoRa is a very you have a lot of implementation of LoRa in the farms, in the big farms. Okay. However, to connect this big farm in the internet, we use another technology. So there are two technologies that is more common in the cities because the cellular network is the LTE and the NB-IoT. Okay, LTE is a subset of the 4G. Okay, I believe all of you already knows or already listened one time in your life the term 4G technology. Okay, 4G network. It's now you have 5G in Mexico, in Brazil, but until 1 year ago, you only have 4G. And the 4G was designed to transport a lot of data, to transport video, to transport voice. But the 4G was not designed to support millions of devices. Okay. Another thing, the 4G is an expensive technology. It's not cheap. Okay. What happened? 4G was designed, I believe, is 20 years ago. And the people said, okay, but now you have IoT, you have multiple devices, many millions of devices that you need to connect. Okay, get part of the specification, simplify the specification, change the specification of the 4G and create the LTE. The LTE is a subset of the 4G that is fit better to the IoT device. The LTE has high data rates, different than the LoRa. You can support, for example, 300 megabits per second. It's a lot of data, okay? In the downlink. In other words, you can download, use 300 megabits per second to download and 575 megabits per second to upload. It's a lot of data. It's a very multimedia. It supports multimedia, for example. It supports video. It supports voice. Okay. The LTE has quality of service. What provide, for example, that the jitter. Remember the jitter that you studied last class. That the jitter, you can control the jitter. But the 4G LTE, again, is a subset of the 4G. When the people start to design the 5G, thinks, okay, one scenario, one case of the 5G is to use in the IoT and design the NB IoT or LTE-M, okay? The NB IoT thinks about IoT. The technology was designed to don't support, to don't consume a lot of batteries. You have an NB IoT device that can, the battery's life is a year, 2 years. You don't have these capabilities in the LTE, okay? And the NB-IoT, the focus is not low latency, it's not the multimedia. The focus is transfer data, okay? And it's the reason that is a chip technology. In other words, the NB-IoT, it's close to like a 5G technology, has support for a lot of data. Okay, you can transport a lot of data, but you don't have focus, for example, in latency. You can, for example, what it means, you can have a device that send the data now, and you spend a long time to arrive to the destination. In the LTE, no. In the LTE, because the LTE is a 4G, it's to design to multimedia. You don't have latency. You control the latency. In NB-IoT, if you can use if you don't have requirements about latency because you don't control. The consequence: 4G LTE is expensive. NB-IoT is cheap. Okay. Another approach is the LTE-M. Is in the 5G technology too, and again, it's a little different than NB-IoT, but it has the same approach: low battery life and low cost. Okay, when you compare the technology, the only technology that you didn't show before is the Sigfox. Why I didn't show Sigfox? Because Sigfox is a standard. Very you find this technology most of the time in the Japan and the China, in countries like that. Okay, in Brazil, Mexico, United States, Europe, you find LoRa, NB-IoT, and LTE-M. Okay, most of the time. LoRa, remember, is no cellular. Use a mesh topology most of the time. Okay, and I'm sorry, is a start with mesh. The good thing, the payload capacity is 243 bytes. What it means? It means that you only can transport small data. Okay, only small data. If you see NB-IoT is 1,600 bytes. It's much more data. LTE don't have limitation. You can transport any size of data that you want. Another important thing, the number of devices that you can have in one cell in the LoRa is 400,000, and NB-IoT 200,000, and LTE-M 1 million devices. Okay. The battery life is around 15 years in the LoRa. In the NB-IoT, 10 years. And LTE-M, 10 years. Okay? And the throughput is another one important thing. It's 5 kilobits, 2 kilobits, and 1 million bits, 1 megabits, sorry. Okay? If you see, LTE-M is the best solution if you have two very big and very performatic IoT network, but it is more expensive, for example, than LoRa. LoRa is cheap. Any question, guys?
No questions.
You really understood what I told today or not? A little.
No, everything good, teacher.
Okay.
I think it is a lot of information, but everything it is good.
Okay. Again, it's only information. Okay. It's a top of our course. However, we really yes, it's very complex, Ernesto. It's already really compressed. Okay. But the idea is only to introduce this topic, to make an overview of this technology. For example, when you watch, when you read, for example, the Cisco, if you revisit the Cisco, probably you have a different understand about what you read, because now you have more information, you have more, you know a little more about the networks. Maybe the reading is this now, okay? So, any questions? No? Okay. I give another break, okay? When we return the break, you discuss the exercise that we work today, okay? We after the break, we will realize one exercise where you use the cloud, okay? You design in Python a small device that sends data to the cloud, and you will configure the cloud to receive the data and to present this data, okay? We install a mini subset of one IoT, end-to-end IoT application, device and the cloud in the next class, in the next 2 hours, okay? So we'll do it after the break, okay? We'll give a break now and return in 00, okay, guys?